Hi everyone, so welcome back to my channel Mathematics Girls 226. In this particular video, we are going to talk on the differentiation of log functions. So I'm going to take all those functions where somewhere or somehow the log will be involved. So yes, this particular video is about differentiation where only log functions I'm going to deal with. So let us directly start with the first question. So we have to differentiate our first function, which is x raised to x. So to solve such kind of question, the very first thing that we should do is we should take this function as some variable. So let us take here this x raised to x as y. So I'm taking this as let y is equal to x raised to x. Now here we are going to use a formula of, or you can say a property of log. And that property is simply that if we have a raised to b, this we can also write down as e raised to log a raised to b. Because here it is actually e log base e a raised to b, which is same as just a raised to b. And this we can also write down as e raised to, this b will come before log, so b log a. So using this property of a log or this formula of a log, we can simply write down this as y is equal to e raised to x log x, right? Now we have to differentiate this function, of course. So this will become dy dx. Remember, we don't call this as dy by dx. We simply call this as dy dx. So if we do the differentiation of this function, so the very first thing that I'll do is differentiation of e raised to x, right? So we all know that the derivative of exponential function is as it is. So it will become just e raised to x. So here at the place of x, we have x log x. So that I'll write down as it is. Now, by chain rule, we have to also do the derivative of this x log x, right? Now this will become e raised to x log x. And now here we are going to use the product rule. What does the product rule say? It simply says that if we are doing the derivative of product of two functions, that is u into v, then we have to keep one function as it is. We have to do the derivative of the other one. Plus the other one as it is, we have to do the derivative of the first one. So using this rule, this will become x, and then we will write down derivative of log x plus log x we are writing as it is, and we will do the derivative of x. That is it. So this is also called product rule. Now e raised to x log x, using this formula, I can just write down the back step as well, right? So e raised to x log x is nothing but e raised to log x raised to x, which is nothing but x raised to x only, right? So using the formula in a reverse way, we can simply write down this as x raised to x from where we had started. And now this will become x, derivative of log x, we all know is 1 upon x by formula. Log x as it is, and derivative of x with respect to x is 1. Remember, whatever formula you are using in any of the questions, make sure you write down that formula on the other side, right? So here I have used the formula of derivative of log x, which is 1 over x, right? Now this will get cancelled. So what we are getting is x raised to x, and then in bracket 1 plus log x into 1, that is log x. So therefore, the answer of dy dx is x raised to x into 1 plus log x. This is the answer. All right, now we can go to the next question. So our next question is, we have to differentiate x raised to sin x, right? So I'm taking all those functions where the log is, going to be involved, as I said already. So yes, we will take this function as y. So let y is equal to x raised to sin x. Again, using the same formula or the same property of a log, we can also write down this as y is equal to e raised to sin x log x. I have directly used the property that I have already written. So this will become e raised to sin x and then log x. Now we'll do the derivative. So this will become dy dx. Derivative of exponential function is as it is. That is e raised to sin x log x, same. And then by chain rule, we have to do the derivative of sin x log x, right? Here, remember one thing, I'm not going to repeat, I'm not writing the formula again and again, but you have to write down every time, for other questions, the formulas again and again. Okay, but here I have written already one time, and like the same formulas, the same properties we are going to use, so that is why I'm not repeating it. So now this will become dy dx as it is, and this we can write on x raised to sine x only, the same way we had written before. And now this will become by using this product rule, by using the product rule of differentiation, this will simply become, if I do the sine x constant and if I do the derivative of log x plus keeping log x constant and doing the derivative of sine x, right? And here it is totally formula based. This is x raised to sine x, and this will become sine x as it is. Derivative of log x is 1 over x, so this is 1 upon x, plus log x as it is. Derivative of sine x is cos x. So again, here I have used two formulas in this particular step, the derivative of log x, so make sure you are writing it on the other side, and derivative of sine x, that is cos x, that also you are writing on the other side. So therefore, the final answer we are getting is x raised to sine x. In bracket, we are getting sine x over x plus cos x into log x, or log x into cos x, whatever you want to write down. And this is our final answer. So this is the value of dy dx. All right, so we are done with the second question as well. Now we can go to the third question. So the third question is, so in third question, we have to differentiate sine x raised to log x. Again, first we will take this function as y, x, z, whatever you want to take, but here x I won't take because x is already involved in the function. So let us just take y only. So let y is equal to sine x raised to log x, right? And now what we will do, we will again use the property of log. So this will become e raised to log x log sine x. Okay, make sure here I'm directly writing, but I have already explained the property or the formula of log. So we are getting y is equal to e raised to log x dot log sine x. Now we will do the derivative. So this will become dy dx. Derivative of exponential function as it is, so e raised to log x dot log sine x. If you basically observe it, like properly, you can see that the same thing is happening again and again. So it's just the question is getting changed, but the formula, the way of solving the questions, they are similar only. And now by using the chain rule, we have to do the derivative of this log x times log sine x, right? So this will become as it is. So this we can simply write down as sine x raised to log x. And then here using the product rule, we can just write down this as keeping log x constant and doing the derivative of log sine x plus keeping log sine x constant and doing the derivative of log x. Simple, it's derivative of log x. Now we can simplify this. So the first step as it is, this is sine x raised to log x as it is. And here if we do the derivative, so log x as it is, your derivative of log sine x using the formula of derivative of log x, it is 1 over x. So this will become first 1 over sine x, and by again chain rule, we will do the derivative of sine x. So that we will do it in the next step. And here this will become log sine x as it is, and derivative of log x is 1 over x. So it will become 1 over x, and then we can close the bracket. So this will become sine x raised to log x. In bracket, we are having log x over sine x. Derivative of sine x is cos x. So we can write down cos x here. Plus this will become log sine x over x. Now we can again simplify this further because we are getting the term cos x and sine x. So we can simplify that further by using the formula. So sine x raised to log x, and then in bracket we are getting log x cos x upon sine x. We know that this cos x upon sine x is nothing but cot x. So using that formula, it will become cot x, and this we can write down as it is log sine x over x. And this is our final answer of dy dx. Okay, so this is the answer. So we are done with the third question as well. Now we can go to the fourth question. So let's move to the fourth question. So we have to differentiate cos x raised to x. So first we will take this as y. So let y is equal to cos x raised to x. Now again, using the property of log, we can just write down this as e raised to x log cos x. And now we will do the derivative. So derivative, that means dy dx, keeping the exponential function as it is, so e raised to x log cos x. And then by chain rule, we will do the derivative of this x, this function, that is x log cos x. Now, this we can just write down as it, like, the back step, that is cos x raised to x. And here, by using the product rule, we will write down, like, we'll keep x as it is, and we will do the derivative of log cos x. And then we will keep this cos x as it is, and we will do the derivative of x. We will log cos x as it is, and we will do the derivative of x. And now we can close the bracket. So now this will become cos x raised to x as it is. This will become x, and here the derivative of log cos x will first become 1 upon cos x, and derivative of cos x is actually minus sin x. So it will become minus sin x. Make sure you're writing the formula on the other side. Plus log cos x, derivative of x with respect to x is 1. So now we can close the bracket. So this will become cos x raised to x, and then this is minus sin, I can write down here x, and this is sin x upon cos x. So first you can notice that sin x upon cos x, this has a formula, and that is tan x. So it will become minus x tan x, and then plus log x log cos x into 1, that is simply log cos x. So it is this. So therefore the final answer is dy dx is equal to cos x raised to x into minus x tan x plus log cos x. If you want, you can also just rewrite this by writing cos x raised to x, and then into log cos x you can write down first, and then minus x tan x. So this is the answer. Now we can go to the next question. So in the next question, we have to differentiate x raised to root x. This is what we need to differentiate. So again, let us take this function as y. So let y is equal to x raised to root x. Of course, we can write down using the property e raised to root x log x, right? Now we'll do the derivative. So dy dx will become, we will write down the exponential function as it is using the formula. And by chain rule, we will do the derivative of root x log x. So let's simplify this. I can just write down this e raised to root x log x as x raised to root x, the way it was written before. And then here we will apply the product rule. So keeping log x constant and doing the derivative of root x, which is same as x raised to half, plus root x as it is and doing the derivative of log x. It's as simple as that. And now in the next step, we can write down this as x raised to root x. This will become log x. Here we are going to use a formula of derivative of x raised to n. We know that derivative of x raised to n by formula, it is n into x raised to n minus 1. So using that formula, it will become half x raised to half minus 1, right? Plus this root x as it is, and derivative of log x is 1 upon x. That is it. This will become x raised to root x. If you simplify this, this will become log x, and then upon 2, and this will become x raised to half minus 1, which is minus half. Plus this will become root x over x. I can also write down this x as root x square, because we know that square and root will get cancelled, so it is actually x only, right? I have done this just to simplify my answer. Now this will become x raised to root x, and this will become here log x by 2. You're using the property of exponent. We know that a raised to negative m will become 1 upon a raised to m. So using this property of exponent, this will become 1 upon x raised to half, right? Here this square and this the square root with this one square root will get cancelled. So what we are getting is just 1 upon root x, right? And now in the last step, we can write down this as x root x, and this will become log x upon 2. This is root x, right? X raised to half, we can just write down as root x, and then plus 1 upon root x. That is it. If you want, you can stop here, or if you want, you can also take this root x common. So if I take this root x common, it will become x root x upon root x, and then inside the bracket, we are getting log x over 2 plus 1. This is what we are getting, and this is our final answer. Okay, so we can just... All right, so we are done with this. Now we can go to the next question. This is a practice video, so we will do as many questions as possible. So now the next question is, we have to differentiate log x raised to sin x, right? Again, the same step. For me, it's very simple because I know how to do this. I know, like, I'm doing the same question again and again. But if you're doing it for the very first time, doing these questions, it's very, very important. So I hope you will just practice as many questions as possible. So let's start with the solution. So we will first start by taking this function as y. So let y is equal to log x raised to sin x. And now we will just write down this as y is equal to, using the property of log, we can write down this as e raised to sin x log x. Because log is together, so I am preferring to write down a bracket over here. Now we will do the differentiation. So dy dx, and this function as it is, which is e raised to sin x into log x, right? And then by chain rule, we will do the derivative of sin x into log x. Right? Now this function we can just write down as it is. Back to the previous one, log x raised to sin x, and here use the product rule. So we will just keep log x as it is, right? And we will do the derivative of sin x. If you just notice the pattern properly, how is it like going, it's just very simple. So yeah, and then we will keep sin x constant, and we will do the derivative of log x. Okay, so yeah. Now we can go to the next step. So it will become simply log x raised to sin x. And then this will become log x as it is. And derivative of sin x, we all know, is cos x. So this will become log x cos x. And then plus sin x. Derivative of log x. So first derivative of log x is 1 upon x. But at the place of x, we have log x. So it is 1 upon log x. And by chain rule, we'll do the derivative of log x again, that is 1 over x. So this is the this is what we are getting, 1 over x, and then now we can close the bracket. So this will become log x raised to sin x, and inside bracket we are getting log x cos x plus this will become simply sin x over x log x. And this is our final answer. So this is the answer of dy dx. All right, so this is the final answer. I hope you are understanding each and every step. Make sure if there is any question that you're not understanding, you have any doubt, you can just let me know in the comment section. Anyway, now we can move to the next question, and that is, so the next question we have is, we have to differentiate sin x raised to cos x. Sin x raised to cos x. Same thing again, we will take this function as y. So let y is equal to sin x raised to cos x. Again, using the property of log, we can just write down this as e raised to cos x log sin x. By using the, we will do the derivative. So this will become dy dx and this will become exponential function as it is, e raised to cos x log sin x. And then by using the chain rule, we will write down this as derivative of cos x times log sin x. And now this will become e raised to, we can just write down, okay, so we will write down this function as it is, like in the question, the way it is written, that is sin x raised to cos x. And now here we will use the product rule. So simply we will write down log sin x as it is. Any one function we will keep the constant first and we'll do the derivative of other function, that is derivative of cos x plus cos x as it is. And now we will do the derivative of log of sin x, right? And now we can close the bracket. Now, in the next step, we will write down this as it is, sin x raised to cos x. And then this will become log sin x as it is. And derivative of cos x by using the formula, it will become simply minus sin x. This is plus cos x, and derivative of log x is 1 upon x, that is 1 upon sin x. And by chain rule, derivative of sin x is cos x. So this will become cos x. And now we can write down this as sin x raised to cos x. In bracket, we have minus sin x log sin x plus here we have cos x into cos x. So if you want, you can also write down this as cos x into cos square x upon sin x. But what I'll do here is I'll write down cos x over sin x as, that means this cos x over sin x as cot x and then cos x. So cot x into cos x. And we cannot simplify this further. So we can leave our answer here only. So therefore the answer is dy dx is simply this one. Right? So this is the answer. Now we can go to the next question. So let's move to the next question. So now we have some inverse functions also involved in the question. So the question is, we have to differentiate x raised to cos inverse x. Okay. So this is again totally formula based. We will start our solution the same way we were starting for the other questions. So let us take y is equal to x raised to cos inverse x. And now using the property of exponent, this will become y is equal to e raised to, this is e, and then this will become cos inverse x, e raised to cos inverse x log x. Now we will differentiate both sides. So this will become dy dx. And here the derivative of exponential function as it is. So it will become e raised to cos inverse x log x. By chain rule, we have to do the derivative of cos inverse x log x. This is cos inverse x log x. And now this e cos inverse x, okay, we can just write down this as it is. That will become simply x raised to cos inverse x. Here, after using the product rule, keeping log x constant, and we will do the derivative of cos inverse x. Plus cos inverse x will keep constant, and we will do the derivative of log x. And now in the next step, we have to use the formula of derivative of cos inverse x, which is direct. We have a direct formula for that. So this will become x raised to cos inverse x as it is, and this will become log x. Derivative of cos inverse x by formula, it is minus 1 upon root over 1 minus x squared plus cos inverse x as it is, and derivative of log x is of course 1 over x. So this was looking different, difficult, but it was not. It was simply again formula based question. So therefore the final answer we are getting is dy dx is equal to x raised to cos inverse x in bracket minus log x over root 1 minus x squared plus cos inverse x upon x. And this is our final answer. Right? Okay. So now we can go to the next inverse function. So now some of the questions are, based on inverse functions. So this is our next question. So we have the function given sin x raised to cos inverse x. Let's simplify this. So this will become, of course, we'll start with this only, let y is equal to sin x cos inverse x. So we will use the property. So y will be equal to e raised to cos inverse x log of sin x. Now we'll do the derivative. So dy dx, the exponential function will be as it is, e raised to cos inverse x log sin x. And then using the chain rule, it will become multiplied by derivative of this function, that is cos inverse x log of, log of sin x. So now we can write down this function as the question only. We can just rewrite down. So sin x raised to cos inverse x. Here we will apply the product rule, as you know. So log of sin x as it is. And by product rule, we will do the derivative of cos inverse x. And now we will keep this cos inverse x as it is. And we will do the derivative of log of sin x. Right? Yes. So now we can go to the next step. So it will simply become yes. So we can just write down this as sin x raised to cos inverse x. And then in bracket, we are having log sin x as it is. Derivative of cos inverse x will become, by using the formula, -1 over root 1 minus x squared plus cos inverse x as it is, and derivative of log x is 1 over x, that is 1 by sin x, and derivative of sin x is simply minus cos x, right? So derivative of sin x is minus cos x. Derivative of sin x is cos x only, not minus sin x, it's plus cos x. All right, so therefore the final answer that we are getting is sin x raised to cos inverse x, and in bracket we are getting log minus, of course, minus sign, minus log sin x over root 1 minus x squared plus this cos inverse x as it is, and cos x upon sin x. For this particular term, we can use the formula, that is cot x. Cos x upon sin x is cot x. So this will become simply cot x, and this is the answer. So this is our dy dx. Now we have to do 2 more questions. So we are on the second last question after this. So let's start with the next question. So x raised to x raised to x. This is what we need to differentiate. So we'll take this as let y is equal to x raised to x raised to x. So here imagine we are having a function like x raised to a function, that this you can consider it as together. Okay. So now if we use the property of log, it will become y is equal to e raised to x raised to x. So I have written this function here, right? And then log of this one, that is x, right? Now we will do the derivative. So this will become dy dx, derivative of exponential function as it is. So e raised to x log x. And then by chain rule, we will do the derivative of x raised to x log x. Right? Now this we can write down as it is, the way it was given in the question, x raised to x raised to x. And this, again, we have to rewrite down this as x raised to x. We know that x raised to x we can write down as e raised to x log x. So I can just write down this x raised to x as e raised to x log x. So here writing these, like x raised to x raised to sin x raised to cos x in terms of this particular formula is very, very important. So e raised to x log x, and this log x I'm writing as it is. Now we will apply the formula of product. So this will become x raised to x raised to x, and here this will become by product rule, I'm keeping log x constant and doing the derivative of e raised to x log x plus keeping e raised to x log x constant, right? And then doing the derivative of log x. Now we can write down this as x raised to x raised to x. This will become log x. Here, if I do the derivative of an exponential function, we know that we have to keep the exponential function as it is because by the formula. And again, by chain rule, we have to do the derivative of this x log x. Plus, here this e raised to x log x, I can simply write down as x raised to x only. And derivative of log x is by formula 1 upon x. So this will become x raised to x raised to x. This will become log x. Again, here this e raised to x log x we can write down as x raised to x. And here again by using the product rule, x as it is doing the derivative of log x plus log x as it is and doing the derivative of x. And here we are getting x raised to x upon x only. And we can close the bracket. So now we can write down this as x raised to x raised to x, and then in bracket we are having log x times x raised to x. In bracket here x, log x derivative is 1 upon x, so into 1 upon x, plus log x, derivative of x with respect to x is 1, so into 1, and then plus x raised to x upon x. And now we can write down this as x raised to x raised to x, and then this will become log x times x raised to x. X will get cancelled, so we are getting 1 plus log x into 1 is log x, and then plus x raised to x upon x. And now we can close the bracket. Okay. So now we can just write down this as x raised to x raised to x, and this will become log x, right? Log x as it is. I'm writing log x as it is, and here we have x raised to x. I'm just multiplying this particular function, okay, with this one, right? So what this will become log x raised to x times 1, that is 1. And then here, remember that this bracket is wrong. This bracket will not come over here, but this bracket will come over here. Okay, because that is another function. And then log x dot log x, that is log x square, and then x raised to x as it is. And then this plus x raised to x upon x, right? Now here what I'll do, I will take this x raised to x common. So if I'll take this x raised to x common, so what I'll left with is log x here, right? And then here log x square. And then here plus 1 by x, right? I have taken this x raised to x outside. This x raised to x, this x raised to x, and this x raised to x has basically come over here. That is it. And now in the final step, we can just rewrite down this as x raised to x times x raised to x. We are having a lot of x raised to x. From here also, I can take log x common. So I'm getting 1 plus log x. And then this is plus 1 by x. Here we can stop because we cannot simplify this further. So therefore, the answer of dy dx that we are getting is this one. Okay, so this is our answer. All right, now we can move to our last question for the day. So our last question is we have to differentiate x raised to x, right? So this is our question. Now to solve this, the very first thing, of course, we will take this as let y is equal to x raised to x, right? So there is a property of exponent that we use, that is a raised to m raised to n is same as a raised to m into n, right? So using this property, it will become y is equal to x raised to x into x, which is same as x raised to x into x is x squared, right? And now we will write down this as using the property of log. It will become e raised to x square log x, right? And now we will differentiate this function. So it will become dy dx derivative of exponential function, which is e raised to x square log x as it is. By chain rule, we will do the derivative of x square log x, right? Now this will become e raised to x square log x. By chain rule, by product rule, we will keep this log x constant and we will do the derivative of this x square plus keeping x square constant and we will do the derivative of this log x, right? Yeah. And now this will become e raised to x square log x as it is. Here we can write down this as log x derivative of x square. Using the formula of x raised to n, it will become simply 2x plus x square as it is, derivative of log x is 1 over x. Now clearly this x and this will get cancelled. So what is the final answer that we are getting? Of course, we can write down this as x raised to x square, which is same as x raised to x raised to x only. Okay, I've written that step also. This will become 2x log x. And then here we are getting just plus x, right? Now from this particular expression, we can take this x and this x common. So I can write down here into x and then inside the bracket, we are getting 2 log x plus 1. So therefore, the final answer is x times x raised to x into 2 log x plus 1. This is not very difficult, as I said, but still, if you're getting confused, do let me know in the comment section. I can just take separate videos as well where I'll be over explaining these questions. Like of course, it's like a short I can upload where I'll explain all those questions again. And if you have understood, please let me know that as well, that you have understood all the questions properly. So that is it for today, and we will meet in the next video with a different concept, with a different topic. Thank you so much for watching my channel. And if you have not subscribed to the channel yet, don't forget to like, share, and subscribe. Thank you so much.